Hello everyone, let's solve a very interesting problem today. Let's have a look at it. We are given two arrays of equal length and we are also given a positive integer k such that we have to choose a subsequence of length k from the first array. For this subsequence, the score is defined as the sum of the subsequence from the first array, and we have to multiply this with the minimum of the corresponding elements from the second array. And we have to return the maximum score that is possible. Let's try to understand this with the help of this example. We have to choose three elements for the subsequence, and if we choose these three, we have to take the sum of the subsequence from the first array, and from our second array, we have to take the minimum of the corresponding subsequence, and the score will be the product of these two. This will be the maximum score that is possible for any subsequence of length 3. Let's try to come up with an intuitive solution for this. Let's just focus on the second array and try to understand what are some possible values for the subsequence of length 5. As we have to take the minimum of the subsequence, let's note down the number in descending order for better visualization. Let's check if 7 can be the minimum of a subsequence of length 5. Since 7 has to be the minimum, the other 4 numbers have to be at least greater than or equal to 7. So we'll try to choose the numbers which are on the left side. We can see that we were only able to choose 4 numbers which are at least 7, and the remaining one number has to come from this part of the array where the numbers are smaller than 7. Since any number from this part will be smaller than 7, 7 cannot be the minimum of the subsequence of length 5. Similarly, if we try to make 8 the minimum of the subsequence, we can only choose 3 numbers which are at least 8, and for the remaining 2 numbers we have to choose something that is smaller than 8. So 8 cannot be the minimum of a subsequence. Now when we try to minimize the subsequence with 6, in this case we are able to choose 5 elements which are at least 6. So this can be the minimum of the subsequence. By using the same logic, any number which is smaller than 6 can also be the minimum of the subsequence. So if we try to generalize this, for any k, the largest k minus 1 numbers can never be the minimum of a subsequence of length k. On the other hand, any number which is smaller than that can be the minimum of the subsequence. This is because it has sufficient number of elements available which are at least that value. Now let's try to see how we can apply our previous intuition to solve this problem. Let's take the complete example for 6 being the minimum of the subsequence. In this case, we have no choice but to choose these 5 elements for our subsequence. And corresponding to those indices, we have to choose these elements in the first array. The sum of these elements will be 53 and we'll have to multiply it by 6 to get our answer. Now let's take a look when we choose this to be the minimum of the subsequence. And corresponding to it, we'll have to choose this number from our first array. Since we have already chosen one element, we now have to choose 4 other elements which are at least 5 for 5 to be the minimum of the subsequence. So we have these 5 elements available, out of which we can choose any 4 to give us the maximum score. For calculating the score, we are multiplying the minimum of the subsequence from the second array with the sum of the subsequence from the first array. And if you notice, the minimum of the second subsequence is already fixed to be 5. Hence, we should try to maximize the sum of the subsequence from the first array. Hence, we should try to pick the maximum 4 out of these numbers, as this number is already fixed. So these 4 largest numbers will lead to the maximum sum, which in turn will lead to the maximum possible score. Similarly, when we are trying to calculate the maximum score possible, when 4 will be the minimum of the subsequence from the second array. So corresponding to it, we have already chosen our first number from the first array. And to maximize our score, we should try to pick the largest 4 out of these 6 numbers. So you might be wondering, how do we choose these largest 4 numbers out of these 6 numbers efficiently? To optimize this operation, we can use a min-heap of fixed size k. The advantage that we get by keeping it of a fixed size is that it will always store the largest k elements. And as we go forward in the array and new elements become available to us, we can add it to our min-heap and then pop the smallest element. So our min-heap will still be of size k, and it will have the largest k elements. Let's see that in action in a complete example. So firstly, we'll sort our second array in descending order. This will make it easier for us to find the minimum of a subsequence. And when we reach 6, which will be the first valid minimum of a subsequence, we'll have these 5 numbers in the heap and we'll calculate the score. And when we try for the next minimum number, we have to choose the number corresponding to it. And out of these 5 elements in the heap, we'll pop the minimum element from it. So now it will store the largest 4 elements. We'll calculate our score and then we'll add 2 to our heap to make it of size 5. Similarly, for our next minimum from the second subsequence, we'll pop the minimum from our heap to get the largest 4 elements. I think this will become much more clearer when we implement the code. The time complexity of this would be, we have to sort our second array in descending order, so this will take O of n log n. And the space complexity would be, we have to sort our array and this will take up some space depending on the library and the implementation. And we also have to keep a min heap of size k. In Python, the sort algorithm would take O of n space. Let's implement our solution. Let's keep a variable to store the result and initialize it to 0. Let's also initialize an empty min heap. To calculate the sum of the k numbers from our first subsequence, we'll keep a variable that stores the sum of our min heap, and as we add or remove elements from our min heap, we'll update the sum stored in it. To find the minimum of a subsequence, we have to sort the second array in descending order. We also have to maintain some order in order to find the corresponding elements from the first array. So we'll zip these two arrays, and based on our second array, we'll sort it in reverse order. So the first number in this pair would be the minimum of the second subsequence, and the second number would be the number from the first array corresponding to it. The first thing that we'll check is if our min heap is already of size k, then we'll pop the minimum element from it, and we'll also decrease that value from our min heap sum. And now since we have to choose the value in the first array corresponding to the minimum value from the second array, we'll add this to our subsequence sum. We'll also push this element to our heap to make it of size k. There's one thing that we have to be careful about, is that we have to calculate the score only when we have k elements in the subsequence. So there can be a case when we are starting and we don't have enough elements in our heap. In that case, we'll not calculate the score. And to calculate the score, we'll multiply the minimum of the subsequence with the sum of the k elements in the heap. We'll use this score to maximize our result. And once we are done with choosing all the minimum values for our subsequences, we'll return our answer. We are done with our solution. Let's submit it. You can see that our solution is accepted. If you have any doubts, concerns, or feedback regarding the solution, please mention in the comments. If this video was helpful, please leave a like and subscribe to the channel for more such content. Thanks for watching and see you soon.